We're in Chapter 6 QuizA, question number 4. Let's take a look at the prompt. Human body temperatures taken through the air are typically 0.5 degrees Fahrenheit higher than body temperatures taken orally. Making this adjustment and using the 1992 Journal of the American Medical Association article that reports average oral body temperature as 98.2 degrees Fahrenheit, we will assume that a normal model with an average of 98.7 degrees Fahrenheit and a standard deviation of 0.7 degrees Fahrenheit is appropriate for body temperatures taken through the air. Question A. An air temperature of 97 degrees Fahrenheit may indicate hypothermia, which is low body temperature. What percent of people have air temperatures that may indicate hypothermia? As we've learned in this class, in order to answer any question, we should make a picture, make a picture, make a picture. So take a minute and sketch your normal curve. Okay, so here's our normal model with a mean of 98.7 degrees and a standard deviation of 0.7 degrees. This is our normal model for air temperature in degrees Fahrenheit. And you see that I've applied our z-score, our standardized values. Our mean is always 0, and the standardized value or z-score that aligns with 97 degrees Fahrenheit is negative 2.43. And again, just a reminder, in order to find z-score, you would take the data value, subtract the mean, and divide that by the standard deviation. So here you go. That's how we got our z-score. And it appears, based on this picture, that a very low percent of the people would have hypothermia. So we're going to use our calculator. And we're going to hit second, vars. We're going to scroll down to normal CDF. And already in your calculator, they give you the lower bound. It's a very small negative number. They actually have negative 1 times 10 to the 99th. My upper bound is negative 2.43. That's my standardized score. My mean for the normal curve is 0. My standard deviation is 1. And I see that the percentage or the area under the curve would be 0.0075. So as indicated by my calculator, this area here is 0.0075. Gotta love technology. Oy vey. Let's try it again. Oh, come on. Oh! Laugh with me, people, not at me. Okay, here we go. So, let's go back to our question. What percent of people have air temperatures that may indicate hypothermia? The answer to that question, about 0.75% of people have air temperatures that may indicate hypothermia. Okay, so let's take a look at question B. Find the interquartile range for air temperatures. So again, let's take a look at our pictures for interquartile range. Well, Q1, as we know, would represent the lower 25% of the data values. So here would be our upper boundary for Q1. And we want to know what is that associated z-score, and we'll calculate that in just a moment. And this would be our boundary for the lower 75% or Q3 on the normal curve. So let's take a minute and calculate our z-score for 25% or the Q1 value. Okay, so in our calculator, We're going to hit second vars, arrow down to inverse normal. We know the area under the curve that represents Q1 is 25% or 0.25. Mu is 0, sigma is 1. And we find a z-score of negative 0.67. That would represent our Q1, our standardized Q1 value for the normal curve. Okay. And let's take a moment and use our calculator again to find our Q3 value. Okay, again, second vars, arrow down to inverse norm. Now the area is 0.75. Mu is still 0, sigma is 1. And surprise, surprise, we get 0.67 as our z-score for Q3. It really should not be a surprise to anyone because our mean is right here, and Q1 would be 25% to the left of the mean, and Q3 would be 25% to the right of the mean. So we expect that they're the same distance, just in opposite directions. So Q3 is always 0.67 standard deviations from the mean, and Q1 is always negative 0.67 standard deviations from the mean. That is always true for the normal curve. So we want to find out what data value would that be, like in degrees Fahrenheit. So let's start with Q1. And here we go. We're going to plug into our z-score. And for Q1, which is 25%, okay, we plug into our z-score formula. Negative 0.67, that is our z-score for Q1, is equal to data value minus the mean divided by the standard deviation. So the data value that represents Q1 in this situation would be 98.2. Okay, and again, we're going to do that one more time for Q3. Q3 represents the lower, right? The Q3 is the upper boundary for the lower 75% of the data. And if we plug into our z-score here, again, it would be 0.67 equals data value minus our mean divided by our standard deviation. And our Q3 value would be 99.2 degrees Fahrenheit. So to answer the question, what's the interquartile range? Well, interquartile range is always Q3 minus Q1. So our interquartile range would be 99.2 degrees Fahrenheit subtract 98.2 degrees Fahrenheit, or 1 degree Fahrenheit. Okay, so we're going to finish up with question 4, part C. A new thermometer for the air reports that it is more accurate than the air thermometers currently on the market. If the average air temperature reading remains the same and the company reports an IQR of 0.5 degrees Fahrenheit, now in the previous question the IQR was 1 degree Fahrenheit, so the new IQR is half of that, find the standard deviation for this new air thermometer. So in this question we're looking to find the standard deviation. Let's make a picture. Surprise, surprise. Oh, your mother's, nephew's, brother's, uncle's, cousin's, sister. I hate when it grabs everything. I think that's good. I think this is good. Okay, so here's our mean. Here's Q1 and here's Q3, right? We just determined that Q1 and Q3 are always going to be negative 0.67 and 0.67 standard deviations from the mean. But in this problem, they tell us that our new IQR is 0.5. Well, that means 0.25 would be to the left of the mean, and 0.25 would be to the right of the mean. So if we take the mean, 98.7, and we add 0.25 to it, we get 98. We don't get 98.45. Sorry. That was a bad calculation. We should have gotten 98.95. I apologize. Let's cross that out. And let's put 98. I make the pen a little thinner. 98.95. Typo. Okay, and if you take the mean 98.7 and you subtract 0.25 from the mean, you get 98.45. Okay, so now we have a new interquartile range of 0.5 degrees. And we're trying to find standard deviation. Well, how are we going to do that? Well, let's pick either one of our data values. We can use 98.95 or we could use 98.45. It doesn't matter. Pick any one data value and plug it in to the z-score formula. Oh, what happened? What happened? Oy vey. I'm telling you, it didn't look like that 2 minutes ago. Oy, ay, 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 ay. Okay. It didn't look like this 2 minutes ago. Oh, it's still very stretched out. I'm sorry. It's the best I can do at this point. So we plug it into our z-score formula, and we get 0.67 equals 98.95 minus the mean divided by standard deviation. Okay? So the standard deviation is 0.37. To answer the question, find the standard deviation for this new air thermometer. The correct answer is 0.37 degrees Fahrenheit. And that's it for Chapter 6 videos. I hope you've enjoyed this great episode of Miss Mac's Academy.